A rectangle has a length of 10 units and a width of 8 units. Squares of x by x are cut out of each corner, and the sides are folded up to create an open box. Express the volume of the box as a polynomial function in terms of x.
Thank you. All right. So again, this is a rectangle, right? 10 units is the length. Okay. 8 units is the width. Okay. And then on this paper, you have to cut out squares on the corners. And what dimension will that be? X by x units are cut out of each corner, right? And then the sides are folded up to create an open top box, right? That's you, right? The question now is to express the volume of the box as a polynomial function in terms of x. All right, so here it is. So again, we have C. Circle the numbers, right? 10 and 8, also x by x. Underline the problem, or what's being asked, to express the volume in terms of x. Okay. B, we box the keywords and phrases like length, width, rectangle, squares, cutout, corner, volume, and open top box. Okay. Now, let's make an equation out of it. Okay. Well, let's visualize first, right? How does it look like? Ready with this one, guys? All right, so here it is. Let's draw first a rectangle of such dimension, right? What did it say? The length is 10. The width is 8. Are we good? Okay. After that, what do? We have to on the corners, right? We're gonna cut on the corners an x by x square. So how many squares are there? 4, right? For each corner, you gotta cut out in here like a square of x by x dimension. We good? Get it? Okay. Same in here, a square as well of x by x dimension. Get it? Okay. Same in here. Okay, and similar in here. Are we good, guys? All right. So if you cut it out, what's gonna happen? Well, they're gonna be gone, right? So this is gone, gone. Okay, so that means in here you can fold along this fold line in here. Okay. Are we good? Right. So if you cut along that fold line in there, how does it look like then, right? So that means in here, it's gonna look like such, right? This dimension is that, okay? Okay. Now this, from this to there, that'll be this one in here. You good? Good, guys, what we did, right? So once again, you cut out this square, right? That square there, that square there, and that square there, right? So what we're gonna get? An open top box like such. Get it? Are we good? Okay, so for example, this is a rectangle, right? You're gonna cut out square in here, square in here, square in here, and square in here. All right, and with that being said, it's gonna look like this one in here, okay? Are we good? Got it? Right? So if you cut a square in here on the four corners and you fold along those fold lines where you cut the squares, then you're gonna get something like this, right? An open top box. Are we good? All right. Now, what are the dimensions of this one now, right? Well, first of all, a while ago, that is 8 inches. Well, 8 units, right? When you cut out a square in here, an x dimension on the other one side, another x dimension on the other side. So how many did you less? 2 x's, right? We good? Right. So with that being said, then the dimension in here will be what? 8 minus 2 x's. Are we good? Once again, this is 8. You cut out an x corner, you cut out another x corner, so the remaining width is 8 minus 2x. Get it, guys? Okay. What about the width? Well, the length, the new length now, right? What's going to happen to 10? Minus 2x's as well. Very good, right? 10 minus 2x's, right? So once again, this is 10 units. You cut out another x, so that's 10 minus 2x length. Get it? Okay. Now, if it's a volume, now what is the height in here? X. Very good, right? Because you fold it along that fold line, and the height of that fold line, see this fold line in here, right? That height is basically what? X units, right? The square that you cut out of. We get? Right, with that being said, to get the volume of this one now, volume is equal to what? For any, what we call, prism, right? A rectangular prism. What you're gonna do with the length, width, and height to get the volume of a rectangular prism, Madeline, multiply together. Thank you, right? Length, width, and height. Then that would be equal to, well, just multiply them together, right? 10 minus 2x, 8 minus 2x times x. Are we good, guys? Okay. Form? That'll be fine. Okay. However, if you want to change it into standard form, what do? You can do foil or box on this side. All right. Good. Okay. Foil and box on this side. What's that gonna be? Okay. So negative 2x times negative 2x. 4x squared. Very good. Okay. What's next? Outer, inner, right? What's this gonna be? Inner, negative 16, right? Outer, negative 20, right? You're gonna add them together, right? What's that? Negative 16 and negative 20 together will be how much? Thomas? Negative 36x. And first terms, right? 8 times 10? 8. Well, do not forget the x in here, right? Well, what you do is just to distribute the x in there, okay? So that means the volume as a function of x is equal to what? 4x cubed minus 36x squared plus 80x. Guys, so that now will be the volume polynomial, all right, as a function of x, and x in here is the what? The height of your rectangular open top box. Okay.